So I'm going to do 4 examples that use some of the homework problems that use vectors to help us solve these things out. These are kind of classic problems that we want to deal with. And I'll walk you through the solution for each one of these things. And here we go. There's an 8-pound weight lying on a sit-up bench at a gym. There's the weight. If the bench is inclined at an angle of 15 degrees, what is the force needed to keep the weight from sliding down the bench? So we can call that friction force, if you will, whatever the case may be. There's a lot of forces in play in here. So let me go ahead and draw these pictures out so you can kind of see what's happening. I'm going to move this off to the side here. I'll just do it down here. So let's look at this bench and let's talk about some of the forces that are involved. So here's our incline at 15 degrees. Here's my weight right here. All forces, if you've never heard this phrase before, everything has an equal and opposite force. So there is a force that is pulling the weight down the bench, and there is a friction force that keeps the weight from sliding down the bench. There's a force called the normaling force, which is always perpendicular to the object that comes out this way. And likewise, there's one going in the opposite direction that way. This is force V. They call this one the normalizing force, and that was N. There's also gravity associated with this thing, and so gravity is always going straight down. So this is the gravity. We're going to call that W. You'll understand why in a minute. And so these are some forces that are being played on this weight. Okay? But because these are 4 vector forces, there is always equivalent forces, you know, and these are just vectors, and so there's vectors of the same direction and length everywhere on this plane. So I can rewrite these forces and move them so that I create a right triangle down here. And this is what it would look like. So here's my picture again. Here is 15 degrees. Here is the weight. Gravity comes down still. And this force that was going, let's do the normal one. So the normal one that was up here, I can slide right back down and put it right there. So there is the normalizing force. Remember that one was going out that way, and here it is right there. This one was over here, and I'm going to put it right there. So this is the W, this one's the N, and this one is the F. And it formed a right triangle. Now, sometimes people have a hard time seeing this, but if I have a flat bench, if it's flat this way, then all of it is pointing straight down. When I tilt it at an angle, this line also tilts at the same angle. So when I go 15 degrees right here, when I tilt it, think of this normalizing force, which is pointing straight out. It was pointing straight up, and when I tilt it, it's going to tilt the exact same degrees that I tilted the bench. And what that means is this is 15 degrees right there. That angle right there. This angle here is exactly the same as that angle there. Because these two forces would have been on top of each other, and when I tilt it, it goes the exact same angle. So this gives me an angle in this right triangle. From that, I can figure out these magnitudes of these things, which is what I'm trying to accomplish. I want to know what force do I need to keep it from sliding down the bench. I need to know that number right there. Well, luckily for us, in our problem, they told us that the weight is 8 pounds. Well, weight is associated with gravity. When you step on a scale, it is measuring how much gravity is pulling you. That is your weight. So that means this magnitude right here is 8. This is 8. Well, that's the hypotenuse. This is the opposite angle. So then I know that the sine of 15 degrees is the force I want, the magnitude of the force I want, divided by 8. And so my magnitude of the force is 8 times the sine of 15 degrees. And then I can use a calculator, and I can figure that out, that it's about 2.071 pounds. Okay? That's how you can do a problem like that. This is a weight on any kind of object on an incline has the same scenario. You'll do different kinds. I mean, you'll have cars on the hill, boats on a boat ramp, all kinds of things that are on a hill sliding down. Our next question is this. A loaded barge is being towed by 2 tugboats, and the magnitude of the resultant is 6,000 pounds. So that means this is 6,000 pounds. Directed along the axis of the barge. That's this axis of the barge right here. Find the tension on these ropes. So what is the force being applied on these ropes? The tension. Okay. T1, T2, if you will. Okay. We want to find the tensions on those ropes. And they make an 18-degree angle with the axis of the barge. Okay, so that's what we're going to be doing there. Let's go do that problem over here. So real quickly, drawing that picture out, here's my dotted line. I have this thing right here. I have this one right here. This is 18. This is 18. This is 6,000. And so what we're going to do, this I call T1. This was T2. Well, T2 and T1 are basically the same. So this is going to come over here to this. And what you end up with is another 18-degree angle here. So this is T2. And they're identical. So I know that the magnitude of T1 is equal to the magnitude of T2. And I know this because this forms an isosceles triangle, which means the 2 base angles are the same, so the 2 lengths of these are the same. And I don't know what that is. I'm going to call it A. Okay, so this magnitude is going to be a length of A in both cases. Once I draw this resultant, which is that this was a resultant at 6,000, I see that I have a triangle. And so I know these 2 base angles, so that means I know this angle right here, and I can use, the triangle sum, which is 180 minus 18 minus 18, and I get 144 degrees. I know this angle is 144. And then I can do law of sines because I have a complete ratio. So the sine of 144 degrees over 6,000 must be equal to the sine of 18 degrees over A. And so then I can cross multiply and solve for A. And 6,000 times the sine of 18 degrees over the sine of 144 degrees. And I can use my calculator here and get an approximate value of 3,154.387 pounds. So that is the tension on that rope. So if I was going to be a tugboat, I need to make sure if I'm going to tug this barge, I got to make sure that it can withstand that kind of pressure on that rope, can pull that kind of thing. Okay, so that is that question. Notice how we're using law of sines and drawing our pictures. Pictures is always important. All right, question number 3. Forces of magnitude 2,000 and 9,000 act on a machine part. I didn't draw the machine part, it's sitting right here. At angles of 30 degrees and negative 45 degrees respectively. So the 2,000 is 30, the 900 is negative 45, along with the x-axis. Find the direction angle and magnitude of the resultant of these forces. So if I'm pulling, there is a resultant that's coming off in some fashion, and I need to figure out where it is. Because this one pulls stronger than this one, the resultant should be above the x-axis, because think of the parallelogram. Okay? So with that, let's go draw this picture out and work this one out. So again, here's the x-axis. I have a 30-degree angle going this way at 2,000. So this is the magnitude, it's 2,000. This is a 30-degree angle. I got a 45 coming this way at 900, and this is a negative 45. Okay? And so what would be the result? Well, like all things in these problems like this, we make our parallelogram. So I need to take this and draw it over here. And this one comes over here in the same direction. And so the result is that right there. That is the resultant vector. We'll call it D, just for the sake of argument. And we wanted to find the magnitude and direction of that result. And the direction is based off the x-axis, so this is the direction angle I need to find, right there. So, how are we going to figure this out? All right. Well, to start off with, let's find this length of this vector right here. So how would I do that? Okay. Look at the parallelogram. I know there's a lot of lines in here, but think of the parallelogram. This angle, even though it says negative 45, this angle here is 75 degrees. And because this is 75 degrees, and in a parallelogram, consecutive angles are supplementary. If this is 75 degrees, then this over here must be 105 degrees. I know this side is 900, that's 2,000. I have the angle in between them. And so then I can use law of cosines to find this measurement. Law of cosine says that d squared must be 2,000 squared plus 900 squared minus 2 times 2,000, 900, and the cosine of 105 degrees. So using our calculator and working this out, we get that D is approximately 2,396.195 pounds. All right, so that is the magnitude of D. All right, so to find the angle that I need for this, I need to come over here and I need to find this vector itself. So what I've done is I've called this vector with this magnitude, I call this one V, and this one down here with this magnitude, I'll call U, because vector D is the result of those two. So this becomes U plus V. So vector D is vector U plus vector V. I have these angles for each of these vectors, and I have the trig form of each of these vectors. So I can find vector V simply by doing the magnitude and the angle. So I know that this is the magnitude of this is 2,000 times the cosine of 30 degrees. And this will be 2,000 times the sine of 30 degrees. This then takes that into component form. And I can work this out. And when I do so, I get 1,000 times the square root of 3. And this over here is just 1,000. So that's vector V. I can do the same thing for vector U. Vector U is going to be the magnitude times the cosine of the angle. Oops, I didn't give myself enough room. And then 900, the sine of the same angle. So U, if I work this out, this is the square root of 2 over 2. So this is going to be 450 times the square root of 2. And this down here would be a negative 450 times the square root of 2. So that is vector V, that is vector U, and I need to add them. So what is U plus V? It is 450, the square root of 2, plus 1,000, the square root of 3, and then a negative 450 times the square root of 2, plus 1,000. This is A, this is B, and the angle is B over A. So we need to work all this out and find theta. So doing the inverse tangent of all that, will give me an angle, which is 8.728 degrees. And that is my direction angle. So there's my magnitude, and there's my direction of the resultant. Okay, one more to do. The last one over here, the airplane. An airplane is traveling at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with a negligible wind velocity. When the airplane reaches a certain point, it encounters a wind with a velocity of 70 miles per hour with a bearing of 45 degrees. What are the resultant speed and direction of the airplane? Because remember, the wind is going to push the airplane. So let's write out what this all says. So the plane, before it encountered the wind, is on 330 degree bearing. So that's all the way over here. And so it's going off in this direction right here. This is 330, which means this is 30, which means this angle right here, its direction angle is 120 degrees. And I'm going to call V1 is going to be the vector of the plane with no wind. So this is V1. I'm going to let V2 be the vector of the wind. Okay? So what's happening? This is what it's doing before the wind occurs, and then the wind is going to start blowing. And when the wind blows, it's going to blow at a 45-degree angle in that direction over there, and it's going to change the way this plane is moving. Here's what it looks like when the wind is blowing. Here was the original vector V. This is the original V1. The wind is blowing at a 45-degree angle. It's going in that direction right here. So the wind basically is blowing it that way. This is vector 2. Okay? This then is the result of that action. We need to find that thing. Okay? The wind, again, remember, was blowing this way at 45-degree angle. I know it was a bearing of 45, but 45 and 45 is 90. So this is the 45 bearing, and that's the angle. And so this is V2 down here, and it's also up there. Remember, parallelograms, right? So how am I going to find all that? Well, let's start off by finding the component form of each of these vectors. I'm all over the place. So the plane we know was going 500 miles an hour. Okay. And we know that this direction angle was 120. So in component form, this is 500 times the cosine of 120 degrees. And this is 500 times the sine of 120 degrees. Working this out, and you get the vector of the plane without the wind to be in negative 250 and 250 times the square root of 3. Now let's do the wind. The wind came in at 70 miles per hour at an angle of 45 degrees. So working that out, we'll see that this is going to be 35 times the square root of 2, and this is also 35 times the square root of 2. We want the new vector, the resultant of this, so we want vector V, which is the plane plus the wind. So then we are going to end up with those two things added, negative 250 plus 35, then the square root of 2, and 250, the square root of 3, plus 35, the square root of 2, like so. And then you can use your calculator to work this out and give me 3 decimal places. So this is going to be a negative 200, 503, and this over here will be 482, 510. Just type that into the calculator, get a decimal, round to 3 places, and there is the vector v, of which I can now find its direction and magnitude. What is the magnitude of v? It is the Pythagorean theorem. It is the square root of negative 200, 503 squared and 482, 510 squared. Using our calculator, we get that the plane is now going 522.511 miles per hour. Okay? The same thing again, we're going to do the tangent then is b over a. Doing the inverse tangent of this one, this is a negative value. So it's going to give me an angle in quadrant 4. Remember, by definition, so we want our angle to be going in the opposite direction. So we're going to have to take our angle and take the inverse tangent of this angle right here, 510 over this, and add the 180 to get us back on the direction that we're traveling in quadrant 2. And when I do that, I'm going to get 112, so 112.6 degrees. Okay, so what is this equivalent to? So this is the direction angle, but what is the bearing then that this imparts on? So this is the angle of our vector, so that is 112.6 degrees. And if I'm doing a bearing though, I have to go from the north line around, so just basically take this right here, 112, so that little sliver right there is the difference between this is from 90. And then you take that away and gives you this. So my bearing, so the true bearing of the plane will be 337.4 degrees. So this is the true bearing of the plane. This is the angle at which it's going. So again, remember, to get the true bearing, take this number right here, subtract it from 90, you're going to get that little angle right there. Okay, and then take that angle away from 360, and that gives me my bearing. Okay, so that's how we do those problems. And use this as a guide to help you when you get stuck or need some assistance in some of the other problems that you're doing.